what is loop and iteration? Before we get started on this, I like to stay on the first page. So loop basically means this, right? It goes back again, something that goes back. What about iteration? Like, what is the difference between loops and iterations? They're synonymous, okay? Loops means in the context of this problem space, I'm just gonna keep iterating, right? So you could have maybe like 5 lines of code right here, okay? And your flow of control, remember what I said, flow of control, right? Your Python interpretation happens from line 1 all the way through, right? From top to bottom, right? Okay, let's say if I want some, that this is line 1, line 2, and line 3, okay? And line 4 and line 5. Like before I get to line 5, right? I want my computer, my program to iterate this between line and 3 and 4. You know, this 3 and 4 iteration, you know, I want to do it 100 times. You know, I want to do 100 times. Okay, you can do that. So what's going to happen is line 1 is going to be called, line 1, line 2 is going to be invoked and evaluated. Line 3 is going to be evaluated. Line 4 is going to be evaluated. As soon as line 4 is done, it goes back to line 3, right? So this is what we call rinse and repeat. So rinse and repeat happens 100 times, okay? This is an example of a loop, okay? And iterations, right? So inside a loop, there could be 100 iterations. So that's the terminology we have here. A loop with iterations within, right? That goes straight, that goes back and forth. Now you may be asking me, is it possible to have a loop that never exits? Sure. Instead of going through 100 times, it will go through infinity. Okay, so this is the infinity simples in mathematics. And that is not good. This is a moment in time where for some it's a rude awakening, because you're gonna see smoke coming out of your computers. I probably catch some fires. No, you're not. But it usually causes your CPU to start, you know, sounding really busy, right? You guys have probably gone through some of those experiences, maybe not, but you may have some bad software running on your computers, and that bad software is sucking up all of your CPUs. You don't know what it is, so you restart your computer. So chances are you have some loops running, right? And if you guys are interested in simulating infinite, this is what we call infinite loop, okay? INF, right? Infinite. But this is really bad, okay? This is really bad. Don't do that unless you're just curious to see what happens. One really good way of bringing down someone else's computer is for example, going back to the IDE online I was talking about and write an infinite loop there, and chances are you might be able to take down that entire server that's hosted in Germany, okay? And there might be 500 users on that machine running their math for their elementary school projects. And then because of your infinite loop, right, it takes down that whole server down. So please don't, if you want to write some infinite loop, try to do it on your own machines. Because these online IDE, these are virtual machines, okay? Virtual machines means there could be 500 instances. It's basically carved out of a physical machine that's hosted maybe in England or maybe at a basement of someone else's house, you know, five miles away, right? In Los Angeles. But wherever these machines are, you'd be using a part of that machine's resources. It's having an infinite loop, it's just gonna suck up the whole machine's resources, right? And you see the CPU training and stuff like that. And obviously the infrastructure is much better and logical than that. They'll terminate you to prevent you know, this thing go on and on. Okay, so that is a brief, okay, overview, okay, of what a loop and iterations are. Okay, let's get on to the specifics by going to the second page here. All right, just like before, we have some pretty illustrations here, repeated steps. N is 5, okay? If n is greater than 0, as long as n is greater than 0, then it's going to keep on doing two things. One is print, and the other one is downgrading, right? Decrement. This is what we call decrements. Okay, so n is 5, right? So this is a variable, that is an integer, right? So we know that because this n equals 5, right? So n is an integer. Now, as long as this is greater, so what is this? This in parentheses here. By the way, you don't have to have it in parentheses, but I'm just trying to illustrate it here. What is in parentheses here is what we call an expression, right? This is conditional expression that we went through 2 sessions ago. So as long as this is expression evaluates to a true, right? Value of true, true or false. True is 1, right? False is 0. Then execute this. The reason why we do that, we know that is because we have indentations here. Like I said, everything that is kind of the same indentations, they are of the same scope. So in this case, what we have scope-wise is what we call control structure scope, right? Or while loop, right? This is what we call while loop. While loop, okay? While loop. And whatever is inside this indented space is what we call while loop. And this one has a loop scope. So this is kind of local to this while. Okay, so first thing is to print it, right? So you're going to see 5 here. 5 is printed. And then the next one is, well, once 5 is printed, and guess what? N equals n minus 1, right? What does that mean? That means n equals 5 minus 1, right? And like I said, you know, the your expression is evaluated first, right? Every time you have a statement right there, equal sign right in the middle. Equal sign is assignment, right? The right side of your, right, quote unquote expression is evaluated first. And then whatever that result is, so 5 minus 1 is what? 4. 4 equals the new n, right? So what happens is you have this memory space, right? And this little space right here is where your n is, right? Your original n is actually sitting right here. And this one has a value of 5 because you gave it to them, right? So by the time that you get to this very first iteration, okay, this is the first iteration we're talking about here. First iteration, 5 minus 1 equals 4. So now this is going to be 4. It's not 5 anymore, right? And then, of course, the very next iteration after that, right? Because what do you think happens after this? After the evaluation of this entire line right here, what do you think happens? This is a loop, right? So there is no breaking point. The only breaking point is your control logic here. Your conditional expression, if it becomes false, that is your breaking point, okay? That is your termination point. But as long as everything is true, right? So n equals 4. So while 4 greater than 0 is still true, right? Then that is your iteration number 2. Okay, does it make sense? So this is iteration number 1. Like every time, the first time you get 5, the iteration number 1. Number 4 is iteration number 2, okay? Number 3 is iteration number 3. So iteration is in blue here, okay? So I used blue. So this is iteration number 4. What about this? Iteration number 5, right? So this means that if I were to write a for loop like this, notice that the for loop has, this while loop has a colon as well. You're gonna be able to iterate these 2 lines of code, print n, and n equals n minus 1, okay? This collection of 2 statements will be evaluated 5 times. Does it make sense? 5 times, sequentially, okay? Sequentially, as the n goes down, each time by 1, until when? N equals 0, right? So at some point, you're gonna have 1 minus 1 equals 0, so n is gonna be 0. So if n equals 0, 0 less than 0 is false. And that will take, right? This will take your iterations out of the loop, and your iteration is going to be completed. And what's going to happen is it's going to have print blast off and then print n, right? And of course, you know n at that point is 0, so very last one is 0. Does it make any sense here, folks? So if this is in the classroom, I will ask you to raise your hand, right, and say something here. But in the absence of turning on your voice, I'd like to get a maybe a yes. Okay, let me see if I left off anything here. Oh, okay. Why don't we go back here a little bit? Okay, what happens if n is minus 5? Then n is greater than 0, right? So basically what happens is this is going to be false, right? This is going to be false. Okay, false means cross, okay? In my terminology here. And if this is false, then none of it is going to be evaluated. So this is not going to be evaluated. This is not going to be evaluated. So what's going to be evaluated is it'll jump straight here, okay? If this is false, it'll jump straight to blast off. So this is exactly what happens here. If this is no, meaning false, okay? So I'm going to use F here. So this is true, yes is true, okay? Then it'll go, if this is false, it'll go straight to printing off this blast off. There's actually an exclamation here because you see an exclamation here. So I just wanted to match the same things here too. And n is going to be whatever the original value of n was. That is not greater than 0, right? Okay, so does it make sense? So what you see here in this program, you have one loop, and this loop is what we call while loop, right? While loop, okay? And how many iterations do we have? How many iterations in this loop? 5, right? The reason why there is 5 is because it's going through this 5 times, right? As soon as the iteration is completed, and that is predicated on your conditional evaluation. Your conditional evaluation is n greater than 0. As soon as n greater than 0 is no longer true, your iteration completes. There is no more iterations at that point. It'll exit that while loop and move on to the rest of the stuff, right? Does it make sense? Any questions about this one? So this is what we call iteration steps or iterative steps. But I guess the author uses repeated step right here. Okay, clearing this one, move on to the next one. This is an infinite loop. This is the, the infamous, your computer catching fire kind of type of deal. And let's take a look at what happens. Okay, so as long as n greater than 0, right? And folks, I don't really recommend that you try this, but if you do it, that's fine too. There's always a way around this. If you do have this running on your computer, you can do Control C, Control D or something like that to exit. The worst case is just turn off your, shut off your IDE, or turn off your terminal or CMD, or whichever environment that you're trying to run it at. And as you can see, that n is never going to be less than 5, right? It's always going to be equal to 5 because there is no decrementations here. So this is going to run on infinite loop, and your code is never going to exit. Because why? Because you have an infinite loop right here. This is never going to be printed, okay? This dry off thing is never going to be printed because this is always going to be true. It's always going to be true, okay? And it's just going to print leather rinse, leather rinse, leather rinse for an infinity of times. So that's bad. Now, if your n is not fitted, it's not going to be giving you a true statement here expression, then you're fine. So if n is -5, then this is never going to be executed, and you'll end up with print dry off, right? Instead. Does it make sense? Any questions about this? So what's wrong with this? Well, there is the infinite loop right there, right? It's all good? Okay. Oh, I can't stress this enough. In Python, Python really loves this thing, okay? This colon here, if you do not have a colon, and also the indentation. So these are the beginning Python's mistake that I see in beginner codes. It's the fail to have these things, but you would have caught this anyway in your development. Otherwise, you would not be able to compile. That's what I meant. Okay, another loop. Okay, so let's take a look at this thing. This thing is never going to reach. Why? Because, well, n is 0, right? If n is less than 3, 0, then print lather and rinse. What I'm saying is this is never going to reach because n is 0, right? And 0 is never greater than 0. So you're going to get this. So the true path is actually here, okay? And this is never going to be reached. Does it make sense? So I just gave you 3 examples. A loop that goes in, a preset number of iterations. The second example is there is no termination whatsoever in this loop. So that is an example of infinite loop. The third example is a loop that never gets evaluated, right? So forget about this while loop. This is a dead code, right? Is a junk. This allows you to bypass it, right? So it depends on this. So as you can see, the most important part is what? Is your evaluation right there, your not evaluations, your conditional expressions, right? If you made a mistake in writing your conditional expression, that is simply a life and death situation, okay? No, I'm just kidding. There's no life and death situations here, okay? Just checking to see if you're listening carefully here. This is the difference between infinite loop and no infinite loop, right? Good code and bad code, okay? Good code versus bad code. Okay, you guys know what I'm saying? Good. Okay, next one. Breaking out of a loop. Okay, so sometimes you'll be having a loop regret, right? Loop regret, as in, halfway through you say, there's no way in heck I'm gonna execute everything. And obviously, as a programmer, you get to decide to do that. And if you don't, then that means your code is not good. Okay, you can write something like this. So you guys remember what a Boolean is, right? This is capital B, Booleans, right? So Boolean has 2 values, right? We talked about this, right? Boolean type. Okay. As a matter of fact, if you were to do this, type and n, what do you get? Well, then what is n? N is true. Okay. What do you think this is going to print? This is going to do something like this, Boolean, okay? Or something to that effect, or don't quote me on this, is because I'm not running a IDE in front of me here, but something like this. Okay, so this tells you that n is a Boolean. Okay, so my point is that Boolean is a conditional expression in and of itself, because you can simply just do this, right? While what? While true. So this might be pretty bad, right? Because while true means it's always going to be true. How do you set it to false? How do you exit out of the while, right? So do not write while true unless, okay? So I'm this is the beginner's mistake all the time. Unless you have some sort of provision to ever break out of the loop, okay? So break means what? Break means that you're breaking out of this loop, whatever, however level deep you are. So you can have nested if loop here and like 3,000 levels, right? As soon as you see a break, what does it break out of? You'll break out of that loop that is associated with. So it'll actually take you to here, right? This break will even bypass this print right here, because this print, remember, is part of the while loop, right? So when I say break, you're breaking out of whatever that nearest while nearest loop is. And then you're breaking, in this case, the nearest loop is this while, right? So how come you're not just breaking this if, but what is if? If is conditional execution, okay? Conditional statement. If is not a loop, right? If is just saying, if this is true, then do something, right? So when I say break, exit out of a loop, break does not exit out of if, okay? It actually looks for the nearest while loop and try to exit out of it. So nearest while loop is right here. And because this is all flushed, right? And you know that break is going to take you into this one, because guess what? This print is on the same level as while. So it's considered outside, right? Outside of that while. Okay, I know this is getting a little confusing because I have so many arrows here. So my point is this break takes you directly from here to here, okay? Line 1, line 2, line 3, line 4. So break is 4. This print line is 5, and then this is 6, okay? So this break at line 4 is going to take you directly to line 6. Okay, does it make sense? This break doesn't just break out of the if loop, because if loop is the if statement, because if is not a loop, right? So when you try to break, you're breaking out of the nearest. Always remember, okay, because sometimes you have nested while loop here. It doesn't matter how many whiles loop you have. This break out of the closest one, okay, the nearest one, which is this guy right here, okay? So this guy, number 1 and number 6, are both on the same scope. So this break takes you out of the while loop, which ends at line 5, and beginning line 6 is the brand new statement. So this break takes you to the print right here, okay? So let's take a look at this, what's going on here, okay? While true, right? So line equals input, right? So whatever the user enters, and you said hello there, right? Okay, fine. If line equals done, but it's not, it'll print out that line, right? So hello there is going to print hello there. Does it make sense to you? And if you enter finished, and that finished is not quote unquote done, right? By the way, when I say quote unquote, it's the same as single quote. So in Python, double quote and single quote is the same thing. It represents some sort of a string instance, okay? Some instance that is collection of characters. As long as what you just enter, which is hello there, is not done, as long as what you just enter, which is finished, that is not done, then you would want to just print the line right here, right? This is exactly what happens here, right? Print the line right there. Okay, cool. But what happens if you print done? Well, if you print done here, then a couple things are going to happen, right? One is, first of all, let me clear this. Right? If you hit done, right? All right, now we got it. If you print done, then this line is going to equal to this. By the way, equals to equals. You're comparing the value, right, of the two. So this done that you just enter on the keyboard is the same as this done that you hard coded in there. Then if statement is going to be true, right? This is going to be true. Okay, then you're going to see break, right? So like I said before, if you see the break, this break is going to look into the nearest while loop, right? And this while loop actually ends right here. So exit out of the loop, right? The nearest loop means exit out of the very last line. So this break is going to jump straight to the very first line after the end of that while loop, right? Which is this guy right here, and print done. Does it make sense? This is the reason why when you key in done in the context of what's on the left side of this code block, that you're going to get done, right? You're going to get done printed. Do you guys have any questions about this so far? Is it all kind of pretty straightforward? And, yeah. Okay. No one says anything, so I assume it's okay. All right. Breaking out of the loop, the break statement ends the current loop and jumps to the statement immediately following loop. Okay, so we already talked about this. This is very clear. It is like a loop test that can happen anywhere in the body of the loop. Yes. So in fact, you can place your break anytime, anywhere you like. But obviously, you know, it has to make sense, right? You don't want to put the break here on the very first line. So if you have a break right here, that is like, why are you writing this while loop to begin with, right? It's kind of silly. So sure, you gotta, usually every time you see, and this is pretty standard, usually when you see a while loop that has while true or something like that, that you know is going to be an infinite loop, there is going to be some sort of break or continue. So there's another keyword called continue. We'll talk about that one in it, okay? And the condition for breaking is always going to be some sort of if loop, right? So while true or something like that, you're going to see a nested if statement with a break in it. And that allows you, right, to break out of a loop if that condition is evaluated true. So condition in this case, line equals done, right? So this is it. Okay. Oh, by the way, in Python, you don't have to use parentheses, but in C++ and others, you have to. So that's what it is. And you got to make sure that this break has the right indentations there, right? If not, then you're going to be in trouble, right? This break will mean breaking out of the while loop for no reasons outside of this if statement. Okay. Okay, so any questions about this? Doing pretty well. All right, the next one. Okay, again, this is reiterations of, Yeah, I think the author is using transporter. Have you guys seen? Have you guys seen Star Trek? Transporter allows you to jump from one place to the other, right? So it's kind of like disappearing in the thin air, right? All of a sudden, and then you reappear again. Yeah, I don't know. This is funny. Yeah, so a lot of times this is what happens. A developer makes entry mistakes where this is never possible. Okay, then you're gonna have a true infinite loop. So using whiles is pretty dangerous. Okay, because you gotta understand the conditions, and sometimes these conditions are pretty abstract, right? Because you're not evaluating each of these at scales. Usually when you look at this if loop and while, you're interpreting like a human brain would. You get to see a limited set of possibilities out there. But hey, the reason why you're using computer is so you can scale the computations. So who knows what the future value for these lies, right? So you can get into an infinite loop. These will be what we call edge cases, right? With something like this, that happens and it's like 1 over 1,000 times. It does happen. It'll put your code into infinite loop. And if Google hire you to write their Google search, and which produces a infinite loop in one of their machines, they're gonna lose millions of dollars, right? So don't write infinite loop. That's another example. I'm just using these examples at random to illustrate something. About the no-nos for ever completing an infinite loop without knowing. Finishing the iterations with continue. So let's just talk about this continue thing and then we'll break, okay, for 5 minutes. Okay, so we talked about break, right? So we know what a break is. So break is kind of like the ultimatums, when you are at a specific lines of code calling for this conditional evaluations. And if true, you want to break out of the entire loop, then that would save you from having an infinite loop. Same thing with a continue, but continue is a little different though, okay? Continue means what? Let's continue, right? Let's continue. Do not break, but continue. But you're continuing already, right? You're inside the loop. You're in the iterations. Why would you have to continue? That's kind of silly, right? Stupid. Why would you do that, right? This is the thing. Okay, so we know break means breaking out of your current iteration, which is this, right? Okay, so we have no problem with break, right? So break is good. Continue means if line 0, okay, let's take a look at this. If line 0 is a pound, right? Then what happens? Continue means continuing with your iterations, with the next iterations, okay? Continue means foregoing what you have currently by jumping into the next iteration. Does it make sense? So what's going to happen is it's going to take you directly back to while loop, okay? So none of this is going to be implemented, okay? So if you have a while, if you have a continue, that means this is not going to be evaluated, at least for that, whatever that iteration is, maybe iteration number 10. And iteration number 10 is going to see the continue and says, I'm done with this current iteration number 10. And done means taking the iterations back to while true. Make sense? And then your iteration number 11 is going to start right here, right? And then as long as this line 0 is not pound, it's going to jump into this line and then just keep on continuing its course. Okay, so you guys understand the difference between the two, right? A continue and break. Break means jumping out of your current iterations. Okay, continue means continuing with the next iteration by foregoing whatever you have left in the current iterations. So do not evaluate what you have currently by jumping to the next iteration. Okay, so here's another example. Let me just go through this one more time. Okay, listen carefully. So this is all good. This is going to keep on evaluating from one to the other, and at some point, line 0, right? Whatever this line is a continuous It's basically a collection of characters. If the very first character is not pound, okay, then what's going to happen is it's going to have a loop that continues that way, because this if is going to jump out of it to the next one, and then blah 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 until this. As long as this is not break, then you're good. And if this is not good, then you will jump into the print, right? Sorry guys, I'm using my mouse, and the mouse just lost its focus. Okay, and then and after your print is done, and then it goes back, right? So this entire loop kind of goes like this, right? Keep going indefinitely until line 0 equals pound. Then continue means do not evaluate further at this moment in time. This moment in time meaning discontinue. Go back to the next iterations, right? Next iteration, of course, is going to be true, and then you have what's happening. What's happening is you don't have evaluation for the bottom portion of that iteration that continued. Okay. You guys know any questions about this at all? Okay, I think it's pretty straightforward at this point. Hold on a second. Let me assess where we are. Okay. Yeah, I did my recording actually has pretty much everything here, so we can you can go through that again. I'll post it. Okay. And I believe what happens here, this is just a evaluation, reiteration of what I talked about earlier. With this continue here, your continue statement, when it is reached, will go back, okay, to the while loop again. So none of the remaining aspect of your loop is going to be for that iterations. It's going to be evaluated. So continuous is basically, in other languages, sometimes they have goto, G-O-T-O. At that moment in time, go back to the next iterations. So this while true is going to kick off another iterations, right? Your flow of control is going to go back and then keep going, come on, hits a continue, and it's going to jump right into the next iteration. And then the next iteration continue all the way to the moment we have break, and that break will start looking up to the nearest loop and says, I must exit out of that loop. So exiting out of that loop, right, means that it's going to be going to printing. It's going to the very first line outside of that loop, which is done. So that's where you get that. Okay. Okay. What about this? Let's say if you have this comment, right? In Python, pound signify comments, right? So you're entering this comment, and this comment 0, it's basically line 0. Is a pound. Then this continue is gonna continue its course, right? And then you're gonna have print this. How does that happen? How does that happen? Like, my question is this. Like, how come if you just put a pound, if you put a pounds here, that means it's gonna hit this, right? And it's gonna continue. And then what happens if you continue? You're gonna get into another user inputs right here, right? This is the reason why there is no outputs. This pound don't print this jumps directly to the print this. So this print this is something that you just enter again. And of course, if you just enter that, and as long as it's not done, it's just gonna print whatever faithfully everything you put in there until you hit done, and then you get done. Okay, all right, so we're roughly 70 minutes into the lectures. Why don't we take a 5-minute break? I'm gonna go into one of those early questions there. I'll try to respond during the break, okay? Or first thing after the break. So we'll see you back in 5 or 6 minutes. All right, welcome back from the break. Let's get into the second section of today's lectures. I also responded to a student's questions regarding 4.4. There are 3 inputs, okay, user inputs. what happens is the very first input calling for hours and minutes, you have to parse those for one of the functions called calculate total costs. Okay, just read the assignment, go through that, and then you'll see it, or you can just respond, not respond, review this recorded sessions. Okay, do you guys have any questions about everything we covered from the beginning of today's? Okay, well, if not, then I'm gonna go on to the very next slide, okay? Clear this. Okay, so this very next one is the same as before. Like I said, every continuum break illustration has 3 slides for it. And this one says, if your line 0 is pound, then continue. So this is exactly what happens. Every time you hit a continue, you basically jump straight into the next iteration, beginning with while true, right? And this is true regardless what this condition is. Your continue always goes back to the next iterations. Now, it is very possible that when you continue, there is no more iterations, you're done. Then in that case, it will go straight into this very next one. So you gotta just look at, right, visually, like what is the end of this while loop? This while loop actually goes from here to here, right? So the end of it is actually here. So this is the end of it. Every time you have this done, this one is the end of it. So break jumps outside directly to this done, but continue goes straight back into iteration. So what's going to happen is, do you think, like the question for you, do you think having a continue is sufficient for you to terminate any loop? The answer is no. It is very possible what you have here in the example, while true. This is an infinite loop right there, okay? So continue is just going to continue to the next iteration. So it doesn't really matter, what this loop is, as long as this is an infinite loop. And continue is not going to help it. You're still going to have an infinite loop. The only thing is it's not going to be evaluating the rest of it, right? But everything else before it is just going to keep going and going and going. And it's not good. Now, break allows you to break out of the loop. This is the only condition that's going to happen. It's going to be helpful for you to terminate. If you don't have anything that terminates it, it becomes an issue, okay? So that is the kind of a difference between the two, continue and break. And notice that we're not talking about Java or C++ where you have semicolons here. So up until this point or ever, you are not going to see semicolons at all in this program, okay? You will see a whole bunch of colons here for sure. That simply gives you a delimiter telling you this is the end of that conditional statement, telling you that this is the end of that while statement, right? Loop statement. So statement means that one line right there, right? Delimiter means it ends right there, which means your execution, your flow of execution sees that and then jumps right into the next line. Okay, so that's what I meant by terminates. Okay, any questions about this particular one? If not, let's get on to the next one. Indefinite loop. So indefinite loop is not infinite loop. So while loop I call it indefinite loop because there is no infinitude associated with it, because they keep going until logical condition becomes false. So this is a good loop, right? A good loop exits, okay? Bad loop is infinite loop, which never exits, which causes computer to go on smoke. So the loop we have seen so far are pretty easy to examine, see, blah, blah, blah. Okay, good. Sometimes it is a little harder to be sure if a loop will terminate. So let's take a look at, like what constitutes an indefinite loop and what constitutes an infinite loop, right? In more depth. Indefinite versus definite, iterating over a set of items. Okay, so going back, review. While loop is indefinite because you don't know how many iterations there is going to be until maybe you're inside that while already, right? And then you can kind of count it. So indefinite loop is while. Definite loop is for loop, okay? So I kind of jump forward a little bit. Definite loop here, for loop. Usually we have a collection of things. So the collection of things could be an array of characters or something like this. in your homework, and one of the students asked that, what is a list? Well, this is a kind of a chapters that we have for list is a data structures, okay? So this list is a collection of things. So think of this list as, in computer science, we call this list an array. Array is a contiguous set of memory that contains usually items of the same type, but in Python, you can have different types, as you will learn later on in lectures later. This list of items like lines in a file. So if you open up a encyclopedia, Webster encyclopedia, you have hundreds of thousands of lines of text in it. Every single line ending with a line break is considered one line. So you have hundreds of thousands of lines, and then you can put every single one of these lines, which is a collection of alphanumeric and spaces and whatnot, inside a collection. So what you have here as a list, it looks like something like this, right? A list is like a collection of things. In computer science, this list is not a circle, it's not it's not a triangle, it's a rectangle, okay? So this is a list. So what you see here, it looks like a, like Lego pieces. This is index 0, index 1, index 2, index 3, okay? So when you have a line of sort, maybe a line, right? Not lines. This very first line goes into this bucket. And then you can have another line that goes into this bucket, right? As you can see here, and just for illustrative purposes, the list or this array or collection of characters, items, grows from left to right, okay? Left side to right side, okay? So what I have here is a list of 1, 2, 3, 4, 5, 6, 7, 8. 8 different items that could be put in there. So oftentimes we have this collection of things, okay, that we can loop through, right? This is very useful because when you write a loop, to loop through it, you give it a definite size. Like how many iterations do you need to go through? And this is what we call definite loop. And let's take a look at what this definite loop is like, okay? All right, so this might be new to you. That's okay. You'll see a for loop here. First of all, for loop and while loop, these are all what we call control structures, okay? For loop, right? And then you have while loop. These are what we call control structures. So structures is a formation of sorts that especially when it's used in the context of control. Control means that you're forming this scope of work that you can kind of control, and within that control area, you can iterate through it. Okay, so generally speaking, a loop, let it be a while or for loop. These are what we call control structures. Okay, in computer science. Okay, anyway, so this control structures here is a definite loop, which is a for loop. Okay, usually in programming text, you're not going to see definite loop versus indefinite loop. I mean, this is a very peculiar thing that is specific to this author's use of terminologies of control structures. Usually we just call them for and while loop. But anyway, the for loop looks like this. This is the anatomy. You have to start off with a for, and this FOR, right? This is not F as in capital F, right? That is not good. So there's no such thing. So for is a keyword. In is also a keyword, right? Print is a built-in function. Okay, so we know what print is. For I, right? Notice that you don't have to declare I. I is just in this case, a number, right? It's an integer. Why? Well, this I, in the context of iteration, is an integer, and usually that integer starts with 0. So here's the thing, in computer science, we like to start off with 0, because 0 is kind of like the starting point for everything, including array indexing. The first item inside this collection of things is 0, okay? So this is very interesting because when you get into eventually, maybe some of you guys are in college, right? Like if you ever take engineering classes, engineers like, or even computer scientists, they like to, start up with a PowerPoint, with a bullets, right? And they'll start off with 0. And then 1 and 2. I do that all the time. And like, if I have something that I want to talk about and I put it in the slide, and I'll start with 0. And you can tell this guy is, or this girl is a computer scientist. They play with arrays because everything starts with 0. And then if this is a English major, or liberal arts major, they'll start up with 1, 1, 2, 3. So that's a joke, okay? That's a joke. It doesn't always happen that way, okay? I'm just saying. So I is actually 0 in this, right? In this, let's print I. So let's take a look at, what do you think is gonna happen? Well, it's already, the answer is here, right? So what is this bracket? This bracket is essentially what I just did, right? In my previous slides, where I have this, basically a collection of items sitting in there. The first one is 5, right? What's the second one? Second one is 4, right? So this thing, using a bracket, is exactly the same as this, right? But this in red is not something that you can draw, right? With Python. So in Python, they use brackets, okay? So that you can signify, this is a basket of items. And these items are ordered, okay? Starting with index 0. The first item is the first one, is the 0. This 0 item is 5. The second one is called 4, and the third one is 3, 2, and 1, and so on and so forth. So for every single one of these things, print them out. So that's why you see 5, you see 4, all the way down to 1, right? So you see these things, 4, 5, 4, 3, 2, 1, okay? And then what happens? And then your for loop is done, right? This is different than while loop, because in a while loop, in a while true situation, we have infinite loop here with a definite loop, right? Definite means finite, okay? Indefinite means it could be definite, but it could also be infinite, which is not good. So when you're sure versus when you're not sure. So for loop is pretty sure, right? I know it's gonna end because there's only so many combinations. Like how big can this basket have, right? You cannot possibly have infinite number of numbers in this basket because you'll be writing this for several years, throughout your lifetime. You're not gonna be able to stop putting stuff into this infinite basket. So for loop gives you a finite sort of iterations to go with. And the number of iterations depends on what you have in the basket, how many items you have. So in this list, right, this is what we call list. So every time, oh, sorry, let me just put this. So win equals, let's say win is a variable, okay? And if I do declare something, even with a space in it, it doesn't really matter. So this is what we call an empty list, okay? Empty list. This empty list has no elements in it, but this win is a valid variable that occupies some memories in computer space, so maybe 24 bytes. And then it's gonna start to fill with items, right? So you start putting items in there. So there are operations that you can do to add items into it, right? Okay, or something like that. Anyway, that is beyond the scope of list. But my point is, you can actually programmatically insert, right, items into this list, right? And then what do you think is going to happen? Sorry, guys, I just remember. I think I did the wrong thing. You have to do insert. No, right? It's this goes back to the API, right? Or win append, right? Append means insert something at the specific, at the very end of that list. So if your container already has 5, 4, 3, append means appending this extra item at the end of that very end of that list. Insert gives you the ability to insert particular items at a specific locations. Okay, so does that make sense? So this gives you a kind of a quick overview of the list, but that's my point. Sorry. And let's say if you want, I'm sorry, so I think this is not right. Insert 0, 5. So at index 0, which is this guy right here, you want to put a value of 5. And what is the next one? Next one will be win.insert 1, comma 4, right? And that will get you this one. And the next one will be insert 3, comma 3, right? At index 3. So this is indexing 0, index 1, index 2. Okay, so this goes back to the indexing part. Anyway, so that is list. Okay, hopefully this is good enough for you to begin your work. My point is going back to this definite loop here. This I refers to the item directly inside this list, this collection. Okay, and it just prints everything one at a time. Okay, so there is no infinite loop. Question for you guys: is it possible that you ever get into a infinite loop using a definite loop? Can you create a infinite loop for this one? I would say yes or no. Pretty hard. For the context, the context behind all of the work that you have so far, you're not going to get into an infinite loop. Okay, so that answers the question. Yes, you can have a user input in a loop. Sure, user input could be anywhere. So you can technically, write something like this. For, right, whatever this is, and then, yeah, you can have inputs, right? X equals, whatever you want to do. So yeah, you can do that. So as long as that user input is a valid statement, and then you're fine. Do we have any other questions here? I am trying to follow along. Okay, I think there's a follow-up to the other questions, but that message is sent in private, so I can't get to it now. I'll do that later. Here's a definite loop with strings. So let's take a look at this. There is a for loop, and there is a list. So this is a list. Like I said, a list is in a collection of items, okay? So in this case, this is a collection of 3 strings, right? 3 names. And string is represented by the single quote or double quote. You can use single quote. So there are 3 items in it. And what's happening here is that you're looping through every single item in this. And the syntax is for, right? So this friend, you can actually rename this friend to I, right? It doesn't matter. And then you simply swap this friend with I here, okay? So for I in friends. So this allows you to quickly write a definite loop there, going through every single item that is available inside that bucket and said, take me to that item one at a time in that order, okay? Order from 0, 1, 2, right? In that order. So this is 0, indexing 0, right? Index 1, index 2. So take me to that index 0, grab that integer, not integer, string, and print it. So that's why you see Joseph here, Glenn, and Sally. Does it make sense? And then after you're through, right, with 3 items, because there's only 3. By the time friend goes into the 3rd one, there's none there. Your for loop is going to exit, and upon exit, you're going to see done, right? This is the reason why after everything, 1, 2, 3. So this loop has only 3 iterations. 3 iterations, and then done. Make sense? This is an illustration of how you can loop through a collection of strings. Next one. This is a simple definite loop here, and if this is yes, okay, let me see what this is. Yeah, if this is yes, it'll print blast off, right? Hold on, let me grab my annotation tool. Okay, move I ahead, right? So what I didn't discuss is the fact that how do you get I from here in the first iteration to here? Well, that mechanism is built into this for, okay? In other languages, you have to actually increment this I, but you don't in Python. Python syntax actually makes it a lot easier for you to understand. So you actually do not have to implement this yourself. This I points to the original index 0, and the increment side of things is taken care of natively by the Python interpreters. So it knows. It'll simply just write. It's kind of like a iterator patterns in Java, where you don't have to worry about the specific location of these items. You can trust that the entire definite loop calling for I in is going to take care of that whole iterations by moving I ahead one at a time, right? So as long as this is not done, the iteration continues. In this case, it's going to continue 5 times because there are 5 items in it. So this is going to be 5x, right? 5 times, okay? 5 times. And printing this I out. So you're going to see 5, 4, 3, 2, 1, and then your iteration is going to be done, and your loop is going to exit, and it's going to print blast off, right? So this is how you would write a definite or for loop with explicit iteration bars, right? Iteration variables that changes each time, okay? So this is also available, the syntax, in Java, okay? In Java 0.6 and later on, but obviously you're not gonna have this. So notice that there is a colon here, right? Same thing with for loop here. So always remember the control structure has to end somewhere, and that ending delimiter is a comma. It's a colon. Okay, it's a colon. It's not a comma. It's not a period. It's not a semicolons either. It's a comma. Okay, it's a colon. C-O-L-O-N. Any questions about this, folks? Okay, all right. Let me exit out of this. Go to the next one. Okay, so I mentioned something about the bucket. I mentioned also something about array. I also mentioned something about a collection. So these things are what I just said. For introductory Python or CS, it's okay. But those things are actually what we call data structures. You can, I mean, just to be more correct, it's you can think of it as a sequence because they are ordered. Okay, it's a sequence of things. So these items are sitting inside some sort of collection and they are sequenced. Okay, and the fact that you can use iteration variables like this. So this I could be X. Okay, you can actually put them. You can actually write them as a Y or J, right? Or K. Okay, or A or B. Okay, it does not matter. It does not matter. Once you have them in this for loop, right, ending with a for I in, and then whatever this is collection that you have there with a colon, that completes the construction of your loop. So at runtime, everything that's inside with the indent is going to be evaluated however many times that is called for, given the size of your basket, right, your collections here. Okay, so this sequence, right, is in orange right here, is the one that kind of dictates the number of iterations you have. So the iteration var plus the number of iteration is explicit, right? This is not the same as a while loop, because in while loop, it's kind of like, you don't know when the condition is going to be done, and you're going to have to keep count of it. But for a for loop, you don't have to do that, because by looking at the size of your string, the size of your collection, or size of your array, you know how many iterations there are. And there's always the n there is always light at the end of the tunnel, because for a for loop, your collection cannot be infinite, right? It has to be size-wise. It has to be a finite thing. So for loop always exits, okay? But while loop, you can get into infinite loop. So these are kind of the differences between the two. Indefinite loop versus definite loop, right? That's what the author is trying to convey in this slides. Questions about this? Okay, well, if not, then the very next one. Same thing. I don't know why there's so many slides. It's the same thing. Okay, let me put this in a different light. Iteration variable sequence, okay, block of code is executed once for each in the sequence. The block of code right here is, the block of code is actually, oops. Okay, I hate it when, you guys, you realize this is actual PowerPoints, right? This is not a PDF. So you can actually change things still, which is bad. So this is the block of code right there, okay? This block, okay? So this block is executed for each items. That's what the second line is for, okay? The iteration variable moves through all of the values and the movement itself is done internally. So this is actually an iterator thing internally, and in a more advanced Python, this is something I would have probably told you. You can actually set up your reference counting mechanisms inside this collections. And you know this collection is 5 elements strong, and then you can set up a pointer that points to a reference, pointing to each element, you know, one at a time until you're done looking. And that is exactly what this for I in this basket is doing, but it totally abstracts the mechanisms of having to look through every single one of these variables and incrementing that iterators to the next pointer or address. It totally abstracts those mechanisms away from you so you don't see it. So that's what makes writing a for loops very, very easy to understand, okay, in Python. All right, any questions about this? I can't wait to the next one. Next one is still the same thing, okay. Sorry guys, I've been writing codes all day, so getting kind of weary here. I equals 5, and then I equals 4, and then I equals 3, right? This is exactly what happens, right? So I equals 5, and then I equals 4, and then I equals 3, right? So this I kind of jumps, right, from one element to the next in that order, right? Sequential order, right? And as soon as it jumps, it prints out the body of that loop, which is print I, right? That's why you have this print I here for each iteration. You have this print I all the way until I equals 1, right? I equals 1. Okay. So what happens when I reaches 1 and this printed and 1 is printed? What do you think happens? Well, there's no more. Okay. So this for loop is going to exit, and it's going to exit out of the entire loop and take you to the line after that. But I don't know what the line after that is. Maybe there's some garbage here. I don't know. But it'll go into that line after you're done. So this is what happens. Any questions about this? Okay. Loop idiom. What do we do in a loop? Note, even though these examples are simple. Okay, fine. There's some examples here. Making smart loop. Some variables, initial values for things in data. Look for something that do something. Okay. I think this is quite philosophical. Why don't we just jump straight to the examples here, and then we can come back and try to interpret what the author is trying to say, because I think this is rather straightforward here. Okay, so for whatever thing this is, right, looping through a set. Now, this set, this is a mathematical set, okay? There's a reason why we're calling these by different names. Collection, array, and now we have set, okay? Set is a collection of, so mathematically speaking, a set is a collection of elements that do not repeat, okay? So in this collection of, in this case, integers, instances, none of these integer elements or integral elements ever repeats itself. So if you have a collection that calls for 9, 9, 2, 3, 4, 5, right? Then that is not a set. Okay, so mathematically speaking, you cannot have a set that has duplicate elements in it. Okay, so no elements ever duplicates in a set. So you're looping through this set. That this is not the point. Okay, the point is looping, not set. But since the author uses set, I'm describing it to you. Set is a data structure in computer science. So this is data structure, and as you can see, computer structure actually came from math, right? There's a lot of math, and because this is all fundamental stuff. So sometimes the data structure reflects what you see in math. Another example of computer science comes from math is the conditional stuff, right? Equals equals, right? Control positive, you know, when true evaluates to true, right? These things are all logic, right? That you study in your 7th grade or 6th grade or 8th grades. Okay, so when you're looping through a set, you're getting the same thing here because the set has a, right? This set is actually a list, right? A list has a sequence here. So for every single item, you have to go by this one line at a time. There is no way you can randomize these things, right? The order of your retrieval is in accordance with the order they're inside this collection, which is a set. So it's 9 first, right? And then 41, right? And then 12, right? So you can't just do, you know, get me the one in the middle, and then after that, give me the last one. No, you can't do that, okay? So writing a for loop, iterate through these items in a set, in sequences, okay? And then obviously you have this after that, right? And then the before the iteration happens, okay? Let's go back to what the heck the user was talking about. This trick is knowing something about the whole loop when you are stock writing code that only sees one entry at a time. Set variable to initial. Okay, this is what we call initializations here. Set some variables to initial value. So this is a very, very important thing. If you recall in the while loop, we said n equals 5, right? So this is what we meant by initialization. In for loop, it's pretty much the same thing. Even though you don't see in that example, there is some sort of initialization step that happens, okay? So this is what we call initializations. So some variable initializations. And this is obviously just going through everything you have in there and whatever you have to. And then you look at the variables. I think this alone is not enough to understand. And it's a very poor example. So let me just go a couple of steps over. I think we're almost done. This is a very interesting examples here. So I'm gonna take the liberty to go through these slides so you can see. So this is one demo, not a demo. It's just a sequential illustration of the sequence of the event transpired. What is the largest number? And it says 3. What about next one? It's 41. So this program outputs these numbers. And as it goes through these collection of items, right? So this collection of items is, 9, 41, right? I think that is the point. So from 3 to 41 to 12 to 9 to 24, right? As you're looping through these things, what is the largest number, right? So iteration calls for loop, right? For I in this collection of, right, 3, 4, right? From 3, 41, 12, 9, 74, 15, which is this collection right there that you see here. What is the largest number, right? So this is the thing. If you have this variable, before you run into that for loop, you want to set a variable, and that is your result, to largest so far. So this largest so far is just a variable. And if you know that collection is all going to be positive, you can pretty much initialize, right? Initialize the largest so far to -1, right? Or -3 or -4. It doesn't really matter. So what is the purpose of this? Well, this allows you to iterate through the rest of it, setting the highest by keeping track of what's the largest so far. So the very moment that you land on, right, the very first guy, which is 3 here, 3 is greater than -1. So the largest so far is 3. Does that make sense? So this is basically what you have, right? If largest so far is less than 3, which is what you have here, right? I'm sorry, I'm using a C syntax here, so it's a little different. So largest so far, this is a Python syntax here. Then what happens? Largest so far equals 3, right? So that's exactly what happens here, right? So you want to use the same logic, right, to keep track of the largest one. So what do you think will happen if we iterate to the next items, 41? Then largest so far is going to be 41 because 41 is greater than 3, right? The previous one is 3. So remember, this is iteration by iterations, right? And the good news is the largest so far is global, right? Because it happens right here. Because it happens right here, like largest so far is actually here, right? In this, there is largest so far equals -1, right? So this is what I call initialization. And then what you do is inside your logic, you keep changing the largest so far by giving it the largest number, basically, right? As you iterate through this data, right? This data is a collection, is a set, right? It's a list of value that you can iterate through in sequence, in that order. So as soon as you land on a new item elements inside this data, that thing is the one that you're trying to compare. So that logic, right? What is that logic in there? If, right, largest so far is less than thing, right? So whatever that thing at that time is, so what do? Largest so far equals thing, right? Does that make sense? So that is kind of the logic right in there. And the reason why you can do that is because largest so far, guess what? It's the global, right? Global to that for loop because I initialized it. I not only initialized it, I declared it too, right? So on this scope, largest so far is already available, right? So you can keep using largest so far inside the for loop here, And guess what? As long as you keep in track of the largest thing, this logic is going to be available for every single item that's inside this data until you're done with the loop, right? Let's say if this data has like 100 elements. So after about 100 after exactly 100 loops, iterations, you get your largest so far. So look at the variable. Does it make sense? So this explains what a smart loop is like, okay? Just one example. So let's go back to our previous one. I'm sorry, I'm just kind of finding where this is, right? So you kind of, I think you get the idea, right? If you're to look at this thing in its upshot, initialization, right? Initializing this largest so far element, which is an integer to a -1, because data, in this case, it's all positive, right? So this is the problem space. It doesn't have to be like this, but for this particular problem we're solving here, the none, right? If is greater than largest so far, then you want to set the largest so far to the number, right? And then you can print them out at the time. So 9 is your largest so far, and the num is the one that's getting found through the iterators, right? So this allows you to persist, right? Changing the state of your code, and that state is global, right? So this is a global variable. So your global variable is persisting the state. The state is kind of another way of saying the attributes or the look and feels of your problem at that given moment in time, carrying the largest number so far, and that largest number so far is going to carry its own until you're done, and you can print it because largest so far is the global value. So after you're done, your value for the largest so far is 74. Make sense? So what does that tell you? Well, this is just problem solving strategies, right? This allows you to kind of persist the largest number that you can ever have inside this variable, and you can write a for loop to iterate through it to get to it. So this is an O event, like one loop, and then you're done. Okay, so I believe the rest of it is, this is another kind of loop examples here. So maybe there's 10 more slides. Yes, there's 10 more slides here. Okay, so this is another loop patterns. So let's take a look at this. So this one says Zork equals 0. Okay, so there's a global val here, and this global val increments itself, and then increment by 1, right? So it's going to be 1 because the very first time that Zork is printed is already at 1 because you have +1 in here. So Zork is going to keep going for the number of iterations that is available, given the number of elements you have in this data. So there's only 6 of them here, which means Zork is going to be printed 6 times, starting with 1. And then every single element inside this data is going to be printed 1 at a time in that sequence, right? And then what happens is, so what is Zork? Zork is what we call counter, right? Counting the number of elements you have there 1 at a time. So this is Zork. It's counter, okay? It's really count. This is, I'm trying to write this literally. I'm basically saying Zork is counter. So this counts the number of times we execute a loop. There's only 6 times. And that is the spirit of this thing, counting the loop. Okay? Yeah, usually you want to call this thing Zork, something that is more, that is friendlier to see. You want to see, maybe just call it counter. Don't call it Zork, because I don't know what Zork is. Okay, the next one is summing in the loop. Yeah, you can use this. So Zork in this case is summation. It's basically the local summation that you can start with 0 first. The very first time, the summation is 9. And then the second time around is 9 plus 41 is going to be 50. And then the third one is going to be 50 plus 12 is 62. So this is exactly what you have, right? And then on the right side here is the value that gets added to it, to the previous one. Okay, so I think you guys get this, and then you're printing out the total summations after that. So this is another example where you initialize something. So initializing something is making it global, and that global value could be persisted to store the previous state of that information that you want to add to or increment to in the next iterations. So that's basically the spirit of this one, nothing else. The one after that, finding the average. Okay, fine. So what is average? Average means you got to sum up everything divided by the number of elements, right? So what you need to do is to keep track of the number of elements and the summations. So this is a combination of the first and the second example. It's keeping track of 2 things. So now you have 2 things. 2 things means 2 variables that you have to keep track of. One is the global count, and the other one is global sum, right? Global summation is easy. Sum plus whatever the value is, which is every single element is inside 1 at a time. And count means count equals count plus 1 every single time. So count is going to be 1, 2, 3, 4, 5, 6, right? Your local summation is going to be 9, 50, right? So on and so forth, because we guys know how to do it. After that, this computation 2500, 25.666 is coming from sum divided by number of counts. Okay. So in order to get to what you need towards the end, you have to have 2 pointers, 2 variables that you need to define. Okay. So that is another examples. So on and so forth. Filtering in a loop. Okay. So this is a pretty interesting one. Now you have this what's called a nested conditional executions inside a loop, right? So this loop is pretty straightforward. We talked about this. Is the value is going to be 9, 41, 12, 3, 74, 15, that order. If the value is greater than 20, then you print this, right? So there are 2 instances where this 20 is going to be true. Greater than 20 is going to be true is when your value is 41 and value is 74. So you're going to see 2 of these printed, right? Before and after. And the only place where this is information is printed is when value is 41 and 74. So you're going to see 2 of these before and after. So This is filtering in a loop. Okay, so these are just examples of how you can apply loops using such using a Boolean variable. So this one is also pretty interesting. You can check to see if a particular value meets the targets that you're trying to find. So this is kind of like searching for a needle, right, in a haystack, right? Haystack is your universe, and there is a needle in there. So which needle is that? Number 3, okay? Number 3. If this is number 3, then guess what? Found equals true. So found equals true is very interesting because what it tells you is you can print this thing, right? Print this thing and the value. So as soon as you found that number, right, that number is printed. Okay, good. Then what happens? Then it goes back again, right? This print after done, it goes back again. So it's going to go back and then print found. And found is already true, meaning you have already found that thing, right? You're just printing the rest of the values here, but there's really no use to these values anymore. So I don't know why the user, what you can do is you can actually break the loop and just exit. Because once you found the needle, why do you have to keep finding another one? There's only one target you're trying to find, right? So yeah, I don't know what they're doing. Anyway, so this is just for illustrative purposes, but hopefully it gives you a different flavor of this conditional. So yeah, in a conditional loop, for a while loop, yeah, you can have user inputs in there. You can also have another statement. You can have another conditional statement. So it doesn't, you can actually juxtapose, right? Mix and match these things as long as the entire logic is the logic that you need to solve the problem. So there's like 2,000 different ways to skin a cat. Okay, that's why sometimes when you write something, sure you can solve that problem, but your approach is just not very efficient. This is what separates a kind of a mediocre programmer from a very good programmer, because everybody can solve the problem, but it depends on how you write it, right? So in this course, this introductory Python, I'm not going to penalize you for how you solve the problem. So the question is more about, can you solve the problem, right? Can you follow the instructions? Can you get this code to compile? Is your code logical, right? Is your code producing the correct results? These are the more important things that I look for in this course than how you solve it, right? Then how, like which path, is that path more efficient, right? So this is more for the next level of course that you may want to take. But okay, you guys have any questions so far? It's 9:05. Well, the good news is we don't have that many left. This is another one that I don't think it needs more. So it looks like it's how to find the smallest value. So we found the largest one. Now this is the smallest value. So all you have to do is to switch the order. This nums greater, right? Just do the order switch. So this is the same thing as we talked about before, just on the opposite side. Okay, so finding the smallest value. So this is the same as the before. This is the largest one, right? This is greater than. The smallest one is less than, right? That's it. And then obviously you want to call smallest so far, not the largest so far. So everything is kind of flipped on the other side. So this is very cool and dandy. Okay, and this is the logic, the entire logic that is going to allow you to print these things and allowing you to find the smallest element so far, which is -1. Okay, actually, the smallest so far, if you see this is a -1, that means there is none smaller than this. So this is a problem. Smallest so far using -1 is a problem, right? So if you know that this is all going to be positive number, so what you want to do is to set up the biggest one. So in Python, finding the minimum and maximum problems in Python is, hold on a second, I think it's called sys max size. So what you need to do is change this to sys max in. Okay, sys max in. But to use sys, you have to, sys means system. you have to import sys on top of it. So you want to set the smallest so far to the largest one ever. That way you can kind of compare that, right? Using -1 is kind of silly. Yep, and or you can change to none. So none means pretty much empty, okay? And this is none, which is a type. You can keep going. So this is good. You don't have to set it to the maximum integer. You can just use none. So the idea is the same, okay? And then you can use this is in, I know we didn't talk about this, but this is another keywords that you can use to compare a type. Is this type, right? This is object. Is this object the same as this other object type-wise? Then if it is, then you can set the values to the smallest one, which is to the very first one, which is 9, right? Because at that point you don't need to do anything else other than just comparing starting with 9. But because before you get started, you don't know the very first element is 9, so you can't really write anything. So that's why you need to just put a label to this smallest. If this is the first time that label is showing, change it to the very first value. Does it make sense? And then moving forward in the future, these variables will be persisted through the collections one at a time and it's never going to get back to none again. Okay. Is and is not operators. Yeah. So one thing I wanted to talk about before we get going here is the difference between the two. Okay. So Python has a is and is not operators. So the is operator is a comparison. So it's using logical expressions. So logical expression meaning this smallest is none is going to return either a true or false, right? So this is the same as. So this is actually doing a object to object comparisons. So equals compares the value of the two objects, but the is or is not compares also the type, not just the value. So type is kind of, so if you guys attended my session last 2 days ago, I was talking about the templates, the class templates. So if you do a type on something, it comes up with a class, right? So that class is a template. So doing a is comparisons there is a stronger than just comparing their values. Stronger in the sense that you're comparing whether the type is of the same thing. So in this case, you're comparing smallest against the type none, right? So if smallest is of type none, right, which is what you have here, then you can assign smallest to the value like this. Okay, so that is one difference between Python and the rest of the other programming languages that you know of. There is no such thing as none in other languages. There is no such thing as a type none, but in Python you can use this approach. Okay, the other approach is what I just mentioned, using sys.maxin to solve this problem. Okay, all right. Without further ado here, because we are towards the end of the session today, we talked about two major control structures. One of them is the while loop, which is the indefinite type, and the other one is we call for loop, which is a definite type. So we have these two control structures that you can juxtapose. You can have a while loop with a nested for loops in there. You can also have for loops with nested while loops in there. Doesn't matter how you use it. You can also have if loop, right? If it's not a loop, it's a control, it's a conditional executions. So if else and whatever inside the while loop, and then you see what I'm saying? So that you can juxtapose these, you can mix and match these things as long as your approach solves a problem of interest. Okay. What's very important in these control structures, this control structures has particularly break and continue. Okay, so these break and continue, these are keywords that can be used in the context of a while loop, but you can also use break and continue in a for loop. Okay, so break and continue is one of them is break out of the current iterations. Continue means go to the next iteration, right? So break and continue also applies to for loop, which we did not illustrate earlier, but is fine. We talked about iteration variables and some of the examples out there that allows you to compute the largest and smallest and to use an if, nested if to filter stuff out, right? So these are just a couple of the examples that you encounters as a software engineer solve problems. Okay, so this is the end of our iteration lectures here.